Hey, welcome back. In today's lesson, lesson number 6, we're going to be talking about the C# data structure. Now, structures in C#, they enable you to group variables, properties, and methods. They're very similar to a class. And structures can be quite involved, and we're just going to kind of skim the top, or we're going to talk about the basic stuff, and that is the variables, properties, and the different methods that you can put inside of a data structure. Now, keep in mind, structures are value types. They're not reference types. Now, what that means is that structures variables contain the values directly rather than pointed to some place in memory. On the next slide here, I got a diagram that hopefully kind of explains that a little bit better. Here's our example here. Let's start with the by value example. Now, here we have two variables declared with the same struct type. And we declare and instantiate the first struct here, and then we create a second struct of the same type, and then we go ahead and we set the second struct equal to the first struct. Now, even though we set the struct2 equal to my struct1, it has its own copy in memory. So what that means is if you change something in the first struct, the changes will not be reflected in the second struct, and that's an example of by value. Now, if you go to the by reference example here, in this example, we're going to use classes. So we have the kind of the same setup here. We have two different variables of the same type of class, and we do the same thing. We set the class2 equal to class1. Now, in this example, if you were to change something in my class2, those changes would also be reflected in the my class1 because they are by reference and they both point to the same spot in memory. So no matter what you do, if you change something in class1, it's going to be reflected in class2 and vice versa. So to further show you the by reference, by value examples here, I've constructed this very simple program that's going to demonstrate and actually show you visually what exactly I'm talking about. And so in here we've got the reference example, which we use classes, and then we have the by value example in which we have structs here. So we're going to go ahead and run this, and we're going to take a look and see what our output is. Okay. So what we got here is the values in both classes prior to making a change. So we have here we've created the class 1, we've created class 2, and then we set the class 1 index. That's just a property in the class 1 here. It's called the index. We set it equal to 1, and then we set class 2 equal to class 1. And then as you can see here, both values are 1. So then we come down and then we set the class 2 index equal to 2, and then we display the values again. And as you can see, now the values are both 2, even though we only changed the class 2 variable. But since they are by reference, they both point to the same spot in memory, so each class gets that change there. It sees the change. So if we come down to the by value example, where in this example here we use the structs, and in here we've got the two structs created, and then we set struct2 equal to the first struct, and you can see here values in both structs prior to making a change here, they're both 1. And then we come down and we set struct2, we change a number, we set it to 2. And then we display them again, and you can see the values in both structs have to make a change to this struct2. And as you can see, the values are 1 and 2. Only the second struct was affected since they both contain their own copy in memory, and therefore the changes aren't propagated to the other struct since they are isolated in their own memory. So hopefully that gives you a better understanding of by reference and by value. Alright, so the next thing we're going to do here is we're just going to dive right into structs. We're going to go ahead and we're going to create a struct. We're going to give it some member variables. We're going to give it a couple methods and a couple properties, and kind of go over the basics of how the structs actually work and whatnot. First thing is structs have to be declared or defined within a class and outside of anything else. So they can't be within the main method here. They can't be inside, within another property. They have to be at least inside of a class somewhere. So since our class here is program, we'll just give ourselves some space here below the main method here, and we'll just go struct, the keyword struct, and we'll call this one car, and we'll go the opening curly brace, closing curly brace. That is bare bones struct definition right there. Now, we can't do anything with this struct right now since we haven't defined any code in it. So let's go ahead and start doing that. Let's create 3 member variables For this car struct, let's call one make, one model, and one color. So we'll go private string str make, private string str model, and we'll do one for color. Now you may be asking yourself, why put private in front of the string? What does that actually mean? And this is something we haven't talked about yet. This is access modifiers, pretty much. And what they do is they determine what type of access that particular variable has. And let me demonstrate here for you. Since these are private, even if we were to create and instantiate this particular struct, and we did my car dot, you notice all we have access to is equals, get hash code, get type toString. But if we took this and took the public off of it, now we have access to that variable. And you can do that if you want to. I wouldn't recommend it. I don't like giving access directly to my variables via this method here. And that's where properties come into play. And we'll get into that here in just a second. So just for now, privates is what we're going to use. So those variables cannot be accessed directly. Okay, let's just put a comment above this here. We'll just call this member variables. Okay. Now let's go ahead and let's create the properties so we can access these particular variables here. Now properties are kind of cool. They're kind of similar to a method. What you do here is the properties have to be public. You have to be able to access them. So we're going to use the public keyword, and then we're going to title it. We're going to give it a name. What are we going to call this one? We're going to do make for the first one. So I'm just going to title it make. Oops, sorry. You do have to have the title there, but you also have to have a type. What kind of type is this property here? And since the make is going to be accessing our string variable, we have to give the type as a string. So we'll have public string make. Then we'll have our opening and closing parentheses. Now you can't just type within these opening and closing parentheses because the properties they need two things, and they're called accessors. There's a get accessor and then there's a set accessor. The get accessor will pretty much return the value of the variable we want. So what we do there is we type out the word get, do opening and a closing parenthesis, and then in here you can just type in return str make. And what that'll do is that'll return the value of the str make. It returns that variable. And then we also have a set accessor. Same thing, opening and closing parenthesis. And in here, we can set the value of that private variable via this property here. So in order to do that, what you do is you type str make the value, or the variable you want to work with, and that equals value. Now value is the incoming value to this particular property. And let me demonstrate that for you. So now that we still have our car struct created up here. So we type out my car and put a period. You see we have make here. If we go over make, it doesn't give us any definitions or anything like that because we haven't defined any. But all you have to do here, if you just do mycar.make equals, what do we want to call this one? We'll call it a Viper. Okay. And that sets this variable now via this public property. And to get it, we do the same thing, except we don't use the equal sign. So we would just do, let's say we had a variable set up here just called make. We could have that equal to mycar.make, and that would set this variable equal to whatever that variable is via this public property. Not sure if Viper would be considered a make. Well, I guess it kind of is, So, that's a bare bones public property, and you can run other lines of code within these particular get and set methods. They don't have to just return and then set the value right away. You can do other things with them as well. But for now, we're just going to leave them just like that. So let's go ahead and create the other two public properties for this particular struct here. We're going to do one for a model and then one for color. All right, now we have our 3 public properties created there. Let's go ahead and use them and see how beneficial they actually are here. So, okay, we have our car struct declared defined there. Now let's go ahead and use it. So first of all, let's go ahead and let's set a make to our particular car here. My car, not my make. My car dot make. Let's just call this one a Cavalier. And then we'll do my car dot make. What am I doing here? This should be like Chevy. Let's do that. And then the model, let's set it to Corvette. And then we'll do my car dot color. We'll set it equal to yellow. Okay, now that we have those set, now we can go ahead and display them. We can do my car dot make, and we don't have to do toString like we have in the past because they already are strings. I'm just going to put some text there. Oops. Alright, what I'm doing here is something I don't think we've talked about yet either, and it's called string concatenation. I know we haven't talked a lot about strings and what you can all do with strings, but what we're doing here is I'm taking a string literal, car make, and have it in double quotes, and I'm using the plus sign to say, hey, I want to concatenate something else onto it that's not a string literal, and then I'm using the mycar.make there. So that'll pretty much combine that all into one full string. Then we'll do the console write line again. We'll do car model, and the same thing. We'll go ahead and concatenate that. My car model. Then we'll do console write line again, and do car color. Okay. Then we'll do console read line. You can do read line or read key. Doesn't really matter. Whichever one you prefer. And let's go ahead and run this. And as you can see, there we got car make, Chevy, car model, Corvette, car color, yellow. Those are all accessed via the public properties of the particular struct that we're dealing with here. Okay, hopefully that helps you understand about public properties in a particular struct here. Now let's go ahead and move on to methods. Methods are going to be similar to what we did before. In the previous lessons there. So let's go ahead and create a couple methods in our particular struct here. Let's do one for start engine and one for stop engine. And again, these have to be public so we can access them. So we'll do public void start engine, opening and closing parentheses, opening and closing curly braces, and then we'll do public void stop engine. Okay, now what we're going to have to know here is whether or not the engine is running. So what we'll need to do is let's create another member variable. Let's make that a Boolean. And we'll title it BLN is engine running. Okay. Now you may have noticed that I haven't been trying to give these member variables a default value. That's one thing you can't do in structs, is you can't say, hey, private string equals, the make. You can't set that. You can't set that right away. I'll show you here. I'll demonstrate that. If we try to actually even compile and build this, right away we'll get an error message saying that, structs.program.car.strMake cannot have instance field initializers in structs. It's kind of a weird error. I'm not sure why they say it that way. But pretty much what it's saying is, hey, you can't give this a default value as you declare the variable. It would be much easier if they just said that. So you have to leave them just created and declared. You can't give them a value. You can give them a value upon struct creation, We'll get into that in just a second here, and that's using a special method called a constructor. But first, let's finish our start engine, stop engine methods here first. Okay, so now we have our Boolean is engine running. So if we want to go ahead and we want to call the method start engine, first we need to know if the engine is running. So we'll do an if statement, bln is engine running, that's equal to false. Then we'll go ahead and change it to true. Else we'll do nothing. Because the engine is already running. And then we'll do the same thing for stop engine. If bln is engine's running is equal to true. We'll set that, then we'll set it equal to false. You really don't need the else here, but if you wanted to do some type of, some type of message saying, hey, you can't do this because the engine's, you can't stop the engine because, first of all, the engine's not running. If you wanted to do, something like that, you certainly could. So we got our two methods here: start engine, stop engine, and then we'll go ahead and give it a public make a public property for that Boolean variable as well. Is engine running? And this one here, we don't want to give a public access to be able to set this variable, because this variable can only be set via the two methods we created, start and stop engine. You can't just call the is engine running property and start the engine that way. It wouldn't work that way. So we want to only give the get accessor to the user of your code here. So we're just going to return that variable there. We don't want them to be able to set that variable via this without calling one of these methods first. So now we have that created there. We'll go back up into our main method here, and then we'll do mycar dot start engine. And then we can just do first of all, let's do console.writeLine mycar dot is engine running. Do a toString there since it is a Boolean. Then we'll start the engine. Then we'll do console.writeLine mycar dot is engine running toString. Okay. Now let's go ahead and run this. So as you can see here, the make, model, and color are empty because I removed the lines of code to set that. But if you come down here to the console.writeLine my car is running, is the engine running? It's false. So we go ahead and we start the engine, which calls this method here, and it sees that it's not running, so it sets it to true. Then we go ahead and we display that again, and now the engine is running. So as you can see, creating methods and calling methods that are in structs are very similar to what we've done in the past. There's nothing too fancy or too new about them. Hopefully that gives you a better understanding of that there. All right, so now we've covered member variables, we've covered properties, we've covered methods. Now let's go back and talk about that special method that I spoke about earlier, called a constructor. And what a constructor is, it's a method that will get called upon creation and instantiation of your struct here. And the way they're done is they are created like this. We'll do the public keyword and we'll title it car, the exact same title as your particular struct that you have going on. And then we'll do an opening parenthesis, and then it needs like a parameter list that we've seen before. And we know that we want to automatically set values for our three member variables, the make, model, and color. So we'll do a string and call it, we'll just call it make, comma, string, and call this one model, comma, another string, and call this one color. and we'll do the closing parenthesis, then we'll do the opening curly, closing curly. And now what we can do here, all right, this is going to have to be below the member variables so it knows that those variables are there. Now what we can do here is we can say, hey, strMake is going to be equal to the make, strModel is equal to the model, and strColor is equal to the color. So what we're pretty much doing here is we're going to be passing in 3 string variables to our struct when we create it, and then we're going to be setting our internal variables equal to those variables that we passed in. So now we can come back up to where we declare and instantiate this. We'll do parenthesis, and we can pass this stuff in. So the make here, we'll pass in Chevy, model will pass in Corvette, and our color will pass in yellow. Alright, now if we try to build this, we're still probably going to get an error message. And it says the fields must be fully assigned before control is returned to the caller. Kind of a cryptic message there. What it's saying is you have a constructor that accepts variables, but you're not setting all of your variables that you have declared. It's complaining about this one right here. You say, hey, if you're going to have a constructor, you need to do something with this particular variable. Well, when the car is created, we don't want the engine running as it's being created. So we'll just go ahead and we'll set that equal to false right away. And that will get rid of all of our error message and satisfy the constructor signature that the actual compiler is looking for. So now, if we come up here and we run our code, we'll get the results as we had before. We have the make, the model, and the color. And then we have the false and true for when we did the engine's running methods there. So just remember, when you're doing a constructor, and you don't have to have, all of these defined in the actual constructor. You can only do one of them, but just remember you're going to have to somehow set these equal to something, or else you're going to get that error message when you go to compile and your code won't even run there. So now I hope you have a better understanding of how structures work in C#. And like I said before, the structures, are more involved than what we went through, but these are kind of just the basic parts of structures at a minimum of what you would probably want to use if you use a structure in your particular code there. So I urge you to definitely practice and play around with structures and see what else you can come up with, use them, and they are beneficial, and like I said, they're very similar to classes. So when we get to the classes lesson, you'll be much more comfortable learning as we go through that particular lesson there. So what's to come in lesson 7? I'm not sure yet. I'm debating between expressions or classes. The reason I might go with expressions is it kind of goes back to a little bit of fundamentals of the actual language, some of the things that we haven't covered yet, such as working with strings, the string concatenation, some basic math stuff, things like that. So I'm not quite sure what we're going to do yet, but it will be, one of those two things, either classes or expressions. So thanks for watching, and I hope to see you in lesson 7.